Hello everyone, welcome back to my YouTube channel. In this video, I want to continue to solve past paper from EJU Mathematics 2018, second session, course 1, question number 2 from section 2. So basically, this is the fourth question from this past paper. If you want to watch the solution from the other problem on this paper, you can check link on the description box below, or you can also check my EJU playlist if you want to watch the other solution from past paper for EJU preparation. Before I start, don't forget to give your like to my videos, or don't forget to subscribe my YouTube channel. Okay? In this question, we have three quadratic functions. The first one is f, which is negative x squared minus 2x plus 1. The second one is g, which is negative x squared plus 4x. And then the last one is h, which is 2x squared plus ax plus b. When we denote the discriminant of quadratic equation h minus f equals to 0 by d1, and the discriminant of the quadratic equation h minus g equals to 0 by d2, we have d1 is equals to blah 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 and d2 is equals to blah blah blah. So basically, I want to find the discriminant of h minus f equals to 0 and h minus g is equals to 0. Let me erase this first, okay? For the first one, h minus f is equals to 0. So first of all, I need to subtract h by f first. I will write down here, h of x minus f of x is equals to 0. H of x is 2x squared plus ax plus b. 2x squared plus ax plus b minus f. Don't forget, you need to distribute negative sign here into there. Or you can write down negative bracket first, like this. But if I directly distribute the negative sign, then I will get plus x squared plus 2x minus 1 is equals to 0. And then I can rearrange or simplify this expression. I have 2x squared plus x squared. Of course, I got 3x squared. And then I will factorize x from these two terms. Then I will get open bracket a plus 2 times x. A plus 2 times x. And then my constant or my independent term of x is b minus 1. Plus b minus 1 is equals to 0. Once you get the equation like this, we can find the discriminant. Remember, the formula of discriminant is b squared minus 4ac. b is the coefficient of x, and then a is the coefficient of x squared, while c is the constant term here. So d1 is equals to b squared minus 4 times a times c. If I simplify it by expanding a plus 2 square here, I will get a squared plus 4a plus 4, negative 4 times 3, negative 12, and then you expand it, you will get negative 12b plus 12. If I rearrange it, I will get a squared plus 4a minus 12b plus 16. This is d1. If you see d1 is a squared plus 4a negative 12b plus 16, so d1 is number 2. And then for d2, by using the same method, first of all, you need to find h minus g first. if I write down here h of x minus g of x is equals to 0, h of x is 2x squared plus ax plus b minus g. Once again, I will directly distribute the negative sign here. So I will get plus x squared minus 4x is equals to 0. And then I need to simplify my expression first. 2x squared plus x squared becomes 3x squared. And then ax minus 4ax, I will factorize x, then I will get a minus 4x. And then last, my constant term is only b. Plus b is equals to 0. Once I got this quadratic equation, I can find the discriminant by using the same equation as earlier, b squared minus 4ac. So I will get a minus 4 squared minus 4 times a times c. By expanding the bracket, I will obtain a squared minus 16, nope, minus 8a plus 16 minus 12b. Then if I rearrange my expression, I will obtain this. Then d2 is a squared minus 8a minus 12b plus 16. Then the correct expression for d2 is number 1. So d1 is this one, this is d1, and then this is d2. And then the next question, the values of a and b such that both the equation fx equals to hx and gx equals to hx have only one real solutions are blah blah blah. You can see here fx equals to h of x. Of course, I can write down as f of x minus h of x equals to 0. If you notice, we already find the discriminant of f of x minus h of x equals to 0. The discriminant is d1. Don't be confused because this is h minus f, yeah. Of course, you can times this equation by negative 1. If you times this equation by negative 1, then I will get negative f plus h equals to 0. Same thing as this one. So the discriminant of this quadratic equation is d1. The discriminant is d1. And then the discriminant of this quadratic equation is d2. As you can see here, if you move g to the right hand side, then you will get 0 equals to h of x minus g of x. The discriminant of h minus g is equals to d2. So we already find the discriminant of these two equations. Since they tells us that there is only one real solution, that means d1 is equals to 0 and also d2 is equals to 0. You need to remember, yeah, for a quadratic equation, if the discriminant greater than 0, that means you have two real roots or two different real roots. If the discriminant is equals to 0, then you have one real root. If the discriminant is less than 0, you have no real root. This is the condition that you need to remember when you work with discriminant. So, since they mentioned that our equation only one real solution, that means the discriminant is equals to 0. So, d1 is equals to 0 and also d2 is equals to 0. From these two equations, I think we can find A and B. I already find D1. D1 is A squared plus 4A minus 12B plus 16. This is my D1. So D1 is equals to 0. And also D2 equals to 0. This is my D2. D2 is equals to 0. As you can see, I can eliminate or subtract these two equations. Then I will obtain A squared minus A squared, of course it is equals to 0. Negative 12b minus negative 12b, you can also cancel out this. 16 minus 16, you can cancel out 16. That means 12a is equals to 0. So a is equals to 0. So your a here is equals to 0. Once you got a, you can find the value of b by substituting your a into one of these equations. If I substitute it into my first equation is a squared plus 4a minus 12b plus 16 equals to 0. For a equals to 0, of course you do not need these two expressions. That means negative 12b plus 16 is equals to 0, then b is equals to 16 over 12. We can simplify it by divide the numerator and denominator by 4. 16 divided by 4 is equals to 4. 12 divided by 4 is equals to 3. So q is 4 and then r is 3. In this case, I will continue it. In this case, the solution of f minus h is blah blah blah, and the solution of g minus h is blah blah blah. So now we want to find the solution. Solution means we want to find the value of x. We want to find the value of x from the equation f equals to h. My equation for f equals to h is this one. As I mentioned earlier, you can move f to the other side. If you move f to the other side, then you will get h minus f equals to 0, which is this one. So for f minus h, my equation is this one. And then you can substitute a with 0 and b with 4 over 3. Then you will obtain 3x squared plus 2x, since a equals to 0, plus b 4 over 3 minus 1. 4 over 3 minus 1 is equals to 1 over 3. 1 over 3. Plus 1 over 3 is equals to 0. And then I will multiply all the terms by 3, so I can get rid this fraction. I will get 9x squared plus 6x plus 1 equals to 0. Of course, you can factorize this expression. If you factorize it, you will obtain 3x plus 1. 3x plus 1 is equals to 0. That means x is equals to negative 1 over 3. So my s and t here is 1 and 3. And then by using the same method, if you want to find the solution of g equals to h, we already know g equals to h is this one. And then I will convert, or I will substitute a and b by using 0 and 4 over 3. Then I will obtain 3x squared minus 4x plus 4 over 3 is equals to 0. Once again, I will times all the terms by 3, so I can get rid the fraction here. I will get 9x squared minus 12x plus 4 is equals to 0. You can factorize this into 3x minus 2. 3x minus 2 is equals to 0. That means your x is equals to 2 over 3. So for letter U and V, U is equals to 2 and V is equals to 3. And then for last question, let B equals to 3. Let B equals to 3. Then the range of values of A such that both F less than H and G less than H hold for any X is blah blah blah. We need to choose the answer from these choices. You can see here, they tells us that F less than H. Don't forget F and H are both quadratic equation, as you can see here. F is a quadratic and H is a quadratic, and also G less than H. G is also quadratic equation. If I try to illustrate F less than H in a graph, you can see that since F less than H, I can try to illustrate it. F is a open downward parabolic. So I will draw open downward parabola like this. I do not know the position of the parabola. Maybe it is here or it is here, I do not know. So I assume F is here, let's say like this. And then H is open upward parabola. Then I will draw another open upward parabola like this. This is h of x. I will give another color for h, let's say blue one. Since f less than h, in graphical, f less than h mean f below h. So all the part of f must be below h. So the condition is something like this. F below h. F below h. My point is, for f below h, that means f and h cannot has an intersection. So f and h has no intersection, because if they intersect like this or intersect like this, we do not know the position, yeah, or intersect like this. Basically, if they has an intersection, if they intersect each other, you can see that there is a region where f is above h. You can see here. This is the region where f is above h. The red one is above the blue one. We do not want this condition. So we only want the condition that f below h. That means they do not intersect with each other. Since they do not intersect with each other, that means the discriminant must less than 0. So, since f and h do not intersect with each other, that means the discriminant of h minus f is d1 must be less than 0. So the discriminant, this is my discriminant for my first function, must be less than 0. So this one less than 0. Same thing for g less than h. G less than h means g is below h. Since g and h are both quadratic, that means for the function for the function g below h, they do not intersect with each other. So the discriminant, which is d2, must also less than 0. This is the two conditions that must be satisfied by A. I will erase this first and then I will move this to here. Since we already know the value of B is equals to 3, then I will get A squared plus 4A minus 12 times 3. B is equals to 3, yeah? 12 times 3 is 36. 36 plus 16, negative 20. Less than 0. You can find the value of A here. I think, can we factorize it? No, I think we cannot factorize it, so I need to use quadratic formula to find the critical value or the value of A. If I use quadratic formula, A equals to negative 4 plus minus square root B squared minus 4 times A times C plus 80 over 2. And then if you simplify it, you will get negative 4 plus minus root 96. Root 96 is equals to 4 square root of 6 over 2. If you divide all the terms by 2, you will obtain negative 2 plus minus 2 square root of 6. And then if I draw a number line, since we are dealing with an inequality, the first critical value is negative 2 minus 2 square root of 6, and then the second one is negative 2 plus 2 square root of 6. If I check the sign by substituting 0, I think, okay, so the sign here is negative, positive, positive. The region that we will take is the negative one, because our expression or our quadratic equation less than 0. So I will take the negative one here. This is the first condition that must be satisfied by A. And then for the second equation, we do the same thing here. This is D2. D2 must be less than 0. If I substitute B into 3, then I will get A squared minus 8A negative 36 plus 16 plus, no, negative 20 less than 0. In this case, we can factorize it into A minus 10, A plus 8, no, A plus 2 I mean, less than 0. So I have two critical values, which is negative 2 and 10. The sign here is negative. If you substitute 0, you will get negative and then positive over there. Since I want the region which is less than 0, so I will take the negative region. After we got two conditions that must be satisfied by A, we can find the intersection. If you find the intersection of these two number lines, you will find the final answer. I think negative 2 minus 2 root 6 is here, and then we have negative 2 negative 2 plus 2 square root of 6, and then 10 over there. The first one is this one, and then the second one is this one. Of course, the intersection is here. You can see, yeah, this is the intersection. So my final answer is negative 2 less than a less than negative 2 plus 2 square root of 6. Plus 2 square root of 6. So my final answer is on number 4. Negative 2 less than a less than negative 2 plus 2 square root of 6. So W is number 4. Okay, that's it for this video. Thank you for watching this video till the end. I really hope I can see you guys on my next video. Thank you and bye-bye.